Merritt, and Belford. I told you it's gonna be a race. And it's Merritt. He's gonna be your winner out of lane number 6.
Yo, making
Hello everybody, this is Wesley Pierre. I'm a student athlete at Merritt College, a part of Sankofa and some other clubs on campus. I am at the library right now and I'm recording this video as I am a student of linear algebra and also discrete mathematics by Derek Smith. Today I'm gonna be talking about some questions that you guys might have on second week of class, and also going to some questions also you might have on the subject that we are learning, linear algebra. And as I made a first video telling you how to get on my open math, Gradescope, and how to do all the tests and everything. Today let's talk about class a little more than your first day, because now it's like your second week. I'm glad you're still here with us and you did not give up on the first week, and let's have some fun with linear. So I watched all the lectures from multiple classes that Derek Smith teaches, and I see some questions that people have on the second week, and it was about the exam 0. So for exam 0 right here, I think you cannot see it, but I hope you can understand what I'm saying. So you have to submit the honesty pledge, and then you're gonna get access to the exam 0, or Professor Derek Smith gonna give it to you. And then after you do that, the exam 0 is something that you're gonna have to keep re-uploading until you feel very comfortable submitting your work, so you can be good for the exam. So that's why people say practice makes perfection. So do it, and it'll be a second nature to you. And when you have 15 minutes to submit it after your exam, it's not gonna be too complicated for you to do. Another question I heard was office hours. People had a lot of questions about office hours. Professor Derek Smith, I have an office hours at 8, and I'm saying this for this semester that I'm in 2024. It might be the same, or there might be a slight difference changes, but it's been like this for a little bit now, so it might stay the same. So office hours, you will find there's one at 8 o'clock a.m., but you need to make sure you get to this one on time, because Professor Derek Smith have another class starting at 8:30. Another office hour is 12 to 1. This one I had to rewatch. After rewatching every lectures, I just realized that this one existed. I thought there was a class on that time. It's the big one, matter of fact, 12 to 1. And then there's another one later after Professor Derek Smith, a discrete mathematics class, which is around 5 to 5:30. This one also you need to make sure you're on the right time, because Professor Derek Smith have a linear algebra class starting right at 5:30. So what are we doing in this class? So this class is right now we are doing chapter 1 and chapter 2, but for chapter 1, this is all the thing you need to know for chapter 1 is equations, matrices, and vectors. That's what we are about to cover on chapter 1. So the first thing, I was trying to see best examples to give you, so you could maybe actually understand the materials better. And I think it's best for me to actually doing the homework, give you an example based on the homework. This is my actual homework. I think it's changed for every student, so I don't think there's gonna be a different me from a different version that's gonna have to take it where this would be cheating. But if it is, I hope they could change it, because I'm gonna make Professor Dex, I'm gonna see this. So this is the first homework, because we are working for those equations, the system of equations, and this was the first one, A. So I am going to do this while I'm telling you the rules that we need for us to kind of like solve this system of equation. So first of all, I know it's a little different than what you used to do in your algebra classes, but it's actually not that unfamiliar. It just built onto it, and it's actually easier than what you used to do. You'll see. So there is something you need to know is we're gonna put those two brackets. Those two brackets I actually also write some stuff based on all the lectures that I've seen. Why did I write this thing? Oh, right here. The brackets is so we could know we're working with one particular object, so we're not like lost. And also, if you're a programmer, you're gonna understand that it's good to keep everything tight and neat so someone else can see what you're talking about, what you're doing. So this bracket is saying that we are working with this particular equation. So first thing we do is, you see, as you were in elementary school, well, I remember I learned this actually, I was 6th grade. You probably learned this when you were like in 3rd grade or something. But every time you see x by itself, there is a 1 right here. People who speak French know about silent stuff. So you don't just say 1x, you just say x, but you know that there's a 1. So what we do is, we took all the coefficient right here, like we do 1, 3, and 3 for y, and 7 for y, and then we do, and just be sure you put those little dots, because that without this, the professor also will be lost in not understanding what you're doing, and I would not even understand. No one will actually get what you're doing if you don't put this there. And that's the rule for doing augmented, how do you call this? Augmented, oh, it's here, augmented matrix. So as you can see, places matters on this thing, and I'm saying this as you see how there's the x here and the x here. I put it y there and y there. I don't just put the x y here, or I don't just put the value the x y here, well, even though it's 3 too, but I keep it just together. Just as I see it here, I put it the same way here, the same way I see it there, I put it the same way there. I just leave the x thing and the y.
The reason why we need to keep it as it is because we need to know what y is and what x is.
There's something you need to know is this thing right here. I hope you can see it. Right here is called, hey, this is column. This is the column. Sometimes I confuse it. And then right here, pow. Up. Right here is the woes. I have a hard time with the R, but it's R-O-W. I either say too French or too American, which sometimes I think it's too American, but it's actually still French. So it's the woes. So right here we could see that we have 2 columns and 3 rows. Easy peasy, right? So now let's start solving this, and then I'll keep telling you more rules as we go. It's not actually that many rules. It's pretty fun. Let's go. So we put our bracket. We say there's 1 here, there's 3, there's 3y, and there's 7y, and then we'll put this little thing as we said earlier, and then -2. I'm gonna write a little big just so you can see it, and then I'm gonna put 2 here. So while we're doing this, there's something we have on our head is we're trying to make this to look something like this. 1, 0, 0, 1, like this, with whatever values. I'm gonna put a star for this. Whatever values. For this, what matters is actually the process that you get the result, not just get the result. Because you could put this some stuff on the calculator or computer and get it, but it's more about like the step you take to get this. So another thing you should know is if you get this to this form, and then you get your result like this. This is actually one solution. If you if you get it to like this and you get the result right here, and then when you look at it, it looks just like this symbol one, the 1001, just like this. I hope you can see this. That is called one solution. But if this thing was 1 0 0 0, and then you would say this with any type of this. Oh, I like this more when it's 3. I'm gonna just do it with 3 so you can understand it better. I'm gonna do it with 3. It's about the same more. So you want all zeros to always be under the 1. That makes sense? And then right here, you want one leading zeros.
You want one
and
leading
then
one.
also what you want is when you go down and then you go to, I would say to the right, to my right, down to the right, and then you need a 1 there. That's how you kind of like keep going at it. You're like boom boom 1, and then right here under the 1 there's a 0, and then 0, and then boom boom, you get another 1 here. So this right here, you see just the 1 right here, and then 2 equals to some type of result. I'm gonna put stars. I don't know if that's a mathematical thing to do, but that's what I'm gonna put for the result. And then this is the one solution. But if it was like this, right? 1 0 0, come down to some type of solution, and then you put 0 0. Oopsie, 1 0. Some type of result, not solution, some type of result, and then you put this again right here. As you can see, this is that, no? Oh, and then if maybe the 1 wasn't there, it was just like this to some type of result. This is to some type of result. This is actually no solution. But if it wasn't like this, you had something like that was just 0. This is called infinitely many solution, and that's all you need to know. Don't pick yourself too much on it. It's good to do it as you go. So I don't. Oh, they have something. Okay, so let's go back to our equation. So we have, what we're trying to do is we're trying to get it to that form that I put earlier, where this is 1 1 and then 0 0 like this. What could we do? I like to make the bottom, the white, the thing that's white under the leading 0, the leading 1 to be 0. So what could I do with this one is do the second row right here. Let's multiply the top row actually by 3. Row 1, multiply row 1 by 3, and then subtract it by row 2. Subtract row 2. So if we do that process, I'm gonna keep writing right here. I'm gonna write it a little bigger for you. And if we keep that process, what are we gonna get? Row 1 gonna stay the same, and then row 2 is where the change is happening. As you probably saying on your head, this is gonna be 0. And why is it 0? When I say multiply row 1 and then subtract row 2, what I'm saying is I have row 1 multiplied by 3 is -3. I'm taking this white there from the row 1, and remember this is the row. And then right here is 3 fois 9. I count in French. That's 3 times 3 is 9. I for some reason have to do every little calculation in my head in French. And 3 times 2 is 6. So -6. So this is what I'm doing technically. And then I have my second row right here. And then I put my second row as it is. And then I put 7. And then I put a 2. this is all the little calculation I'm doing. Multiply with 1, more 3 by 3, and then just subtract it like that. Instead of having to get a big number. So this would be just equals to 2. And this would equals to
4. Wait, I feel like I'm missing something. The negative 6 is still there. So this is negative 6, that's negative 4. But there's one thing that I messed up here is negative. We have the negative 6, and then minus negative 2. So that's negative 8. So that's how I did it on the computer, and it say, you're right, Wesley.
Then you see what I just did here? You will be able to just do this on your head and not having to go here, because sometimes when I have to put it from here to here, it get confused for me. I can just do it here. But at first, it's good to do this here so you can actually have it on your head. So what I'm doing is, technically, it's this. It's just adding those two. It's 3 plus minus negative 3, that's 2, that's this, and then 9 minus negative plus minus 7. It's just like this. Or you don't have to see all those plus. It's just 3 minus 3, it's just 9 minus 7, it's just negative 6, and then minus negative 2, which is just like negative 6, plus negative 2, which is just you adding those two, it's just negative 8. Minus and plus another minus is minus. So I hope you understand that too, because that's something you learn on algebra, but if it was multiplication, it will be adding. You know this already. Okay. Now, this is what we got here. I'm gonna close my bracket so the professor know I'm working with one thing, and then this is gonna be 2, and this is negative 8. Woohoo! That's the first question on your open math, and it's gonna say correct. And then what was the next step I did here? They don't show me the step, but let's just do it. Let's just do it from scratch. So what am I trying to accomplish? I'm trying to get this to be 1, this to be 1, and then with some result. Result doesn't matter right now. What I could do is, I could make this equal 0, but how would this help me if this is 0? Because I need this to be equals to 1. I think it's best for me to go for the 1 first, because the 1 I can multiply by anything to get that thing out of there. So what's the best way for me to do this? There's multiple ways to do this. Let's do the way that I'm thinking first. So you could just do the second row by 1/2. Then you get the 1, and then you can just cancel. You just can cancel this from the 1. Let's do that. So what I'm gonna do is, I'm gonna do a multiply second row by 1/2. Multiply second row, row 2. Let's do row 2 by 1/2. Right here. I don't know if you can see that far. So if we multiply just the second row by 1/2, we're gonna have the same one row because we're not doing anything with it yet. And then we equals to 2, and this is gonna be 0, and this is gonna be just 1, and this is going to be just negative 4. Oh, I love that. When I did this before, I did not do it like that. I tried to get those two equals to like 6, and I'll do a whole thing. It made me take a long step, but that's easier. I guess when you do it, the more you do it, the better you get at it. Now things are looking clear. What we only need to do is get rid of that 3, because remember, we're trying to get this to be 1, 0, 0, 1, and then boom, 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 with some numbers result and some numbers result right here, and like this on this form. So what we could do is, let's multiply. Now this change, we're trying to make the change to affect row 1. So whatever I'm going to do right now, I want row 1 to, I'm trying to affect row 1. In order for me to affect row 1, I need to multiply row 2 by negative 3. Would 2 multiplied by -3 plus Would 1. So the thing is, yes, I could just do the same thing I did. I usually like to put the negative, even though some people don't like that. But I'm going to do that. So it's okay. I could just do multiply by 3 and then say minus 1, but I'm just gonna do multiply by -3 and then plus 1. I like plus more than minus. So I'm gonna make it big so you can see it. I'm gonna make, and then, so now what do we do? Would 2 is gonna stay just as it is, -4. Remember, I say multiply this just so we can get the Would 1. Let's do this here so you can see it very good. I'm gonna go quicker than I did earlier. So right now, the Would 2 is gonna be 3 times 0 is 0, and then -3, and then what I can do is that's -12. Of course, it's not -12, it's just 12 because it's -3 right here multiplied by -4. That's just 12, and then I'm gonna add this one to it, which is 1, 3, -2. Oh, really? Yes, it is. So, and then let's try to get a result here. I'm still gonna get my 1. I'm gonna get a 0 here, and then that's just gonna equals to 10. Easy peasy. So this is Would 1 now. And then we got Would 1. We're gonna put it right here. 1, 0, and then we put the little dot, and then we get 10. And this, as I just told you earlier, this has one solution. Just because we have the y right here, and then we have the x right here. So this is one solution. And then if you cannot see it because it's too far, it's 1, 0, and then we put the 2 dot, and then it's 10, and then 0, 1, and then we -4. Based on this, you can already see, just because I keep this on the same arrangement, that x equals to 10 and y equals to -4. Easy peasy. And you can understand something is, I had already get my y even here, but I manipulated, well, I cannot keep everything. Yeah, I manipulated just to get my Would 1. Sometimes you can even change stuff too, because it's good to just start with the leading one. Sometimes you could even like swap. You could swap, and sometimes you might get the answers that you want for y. You still keep using it so you can get the x. And that's it. For the first 1 and 2 weeks, that's all you're going to do. And if you understand this, if you have any questions, as long as I'm not dead, I hope I'm not dead. Actually, if I'm not dead, I can just reply to your comment on YouTube, and then, or anybody else can just reply to it. But I will reply to it though. I'm glad you're still in the class. It's a very fun class. And if this was a little confusing the way I was showing it to you, please comment so I can change it next time. I love you. Have a wonderful day, and peace out.